Hello, HSE people. So the first 5 days of remote learning are really going to be more of a review of some of the topics that we've been covering, some of the main points that you're probably going to see on the task exam. And so one of the greatest standards that show up with the most amount of frequency on the task exam are talking about algebraic skills and functions. So that's going to be the first day of what we're going to be focusing on. And this is all stuff that we've already covered, so this should be a review. However, if you are struggling, that's fine, right? I'm going to link to some other videos that I've made to help you review with this. But then hopefully these cards should help you figure out exactly what you need to be focusing on. So the first topic that we're going to be talking about is operations with polynomials. This is an algebra skill, right? So this is algebra. Right? And when we're talking about operations, we want to focus on a few in particular. So at the top of your review sheet, right, you should have a little bit that says what you should know and what you should be able to do. And this is a good way to check whether or not you really understand a lot of the topics that we've been covering in this unit on algebraic skills, specifically working with polynomials, right? And so let's just go over a few of these. A monomial is a single number, a variable, or a product of one or more of those variables. So that could be like the number 5, x, 4xy, etc. Right? A polynomial is a monomial or a sum of monomials, right? So this can look like, this can look like 2x plus y, or we can do 3z minus 1, or we could just do 3z, right? A trinomial, this is something that we've been focusing on particular with, especially if the trinomial is like quadratic, right, is an expression that's made up of 3 terms or 3 monomials. So in this example you see here, right, you have the monomial 3x squared, and then you also have the other monomial 7x, and you're going to subtract it with 10, which is another monomial, right? Like monomials have the same variables and exponents, different coefficients. So you're trying to see which ones can be like terms. So this is really talking about like terms. And we know that we can combine like terms, right? And whenever we're dealing with polynomials, we want to make sure that we're in standard form. So standard form is when the terms of a polynomial are arranged so that the exponents decrease from left to right. So we really want to see whether our highest power is first and whether our lowest power is last, right? The degree of your polynomial is the greatest exponent, right? So whenever we're talking about degree, we're talking about exponents, right? And then to add or subtract polynomials, you want to combine like terms and take special care of signs. So you want to make sure that you're watching your signs, right? So this is really just combining like terms. To multiply and divide polynomials, we want to apply the rules of exponents, right? We covered rules of exponents, especially when we were dealing with quadratics and taking out the greatest common factor, or when we were dealing with higher degree polynomials that we could factor out to quadratics by taking out an exponent, right? So when we multiply or divide coefficients, we add or subtract the exponents, right? So when we multiply two terms with exponents, right, we're actually adding them. And when we're dividing exponents, you're actually subtracting them, okay? And don't forget to distribute if necessary, right? And then when you're squaring a binomial, right, this is actually the same as just expanding out to where you're multiplying the expression by itself. So you can use some of the methods that we learned about with multiplying polynomials, right? So some stuff that you should be able to do is adding and subtracting polynomials by combining like terms, right? We're going to stress this over and over again because this is what most of those questions look like, right? So remember, some keywords that you want to be focusing on are sum, which means add, and then difference, means subtract. And then you want to be careful whenever you see this phrase subtracted from. Let's say that you have the expression 4 subtracted from 10, right? That's actually going to be 10 minus 4. So you want to switch around the order of the numbers. When you're multiplying, right? When you're multiplying two monomials, right? You're just multiplying the coefficients, multiplying the terms with exponents. And then when you have a monomial being multiplied with a polynomial, you just want to do straight up distributive property. When you're multiplying two binomials together, you want to do double distributive property. We've actually called it FOIL in our class, so this is the same as FOIL. Or you want to use the box method. And then a binomial and a polynomial, you can either use FOIL once again or the box method, but you just got to expand your box out. Okay? So let's actually go through some practice problems and see whether or not we need to review any of these specific concepts. So our first practice problem is asking us to write an expression that is in the fourth degree, has a leading coefficient of -3, and a constant of 2. Okay, so there can be many different answers for this, but then let's actually make sure that we're taking care of some of the key information that we have. So our expression is to the fourth degree. So this really means that we want the highest exponent, right? So this means highest exponent is going to be 4, right? So our leading coefficient, right, our leading variable has an exponent of 4. Great. So let's look at the next piece of information that we have. Now, we have a leading coefficient. Okay, so that's going to be the coefficient in front of my variable that has the highest exponent. So let me just mark that up, right, that this coefficient is going to be in front of that leading variable. Okay, and then I have a constant, right, so this is just going to be a regular number. So this constant of 2 is just going to be regular number. Okay, so let's actually write an expression. You do not have to write this exact expression, right, but then when you're making your expression, it should look something similar to this, right? So I know that my leading coefficient is going to be -3. So let me just write -3. And that's going to be the leading coefficient for my leading variable, which should have an exponent of 4, since my expression is in the fourth degree. And then I have a constant of 2. So I know that I'm going to have +2, right? So that's one example of what your answer can look like. It would have also been acceptable to do something like -3x to the fourth plus 2, and then put some other term in there like -5x third, right? As long as this term, like whatever term you're adding to this, right? As long as this term doesn't have a higher exponent than 4 and isn't another constant, you're fine, right? But it really should have, your entire expression really should have these, let me see, let me change the color. Your exponent really should have these two elements, right? As long as it has those two elements, you're fine. Okay, let's try the next one. So your next one is saying, what is the sum of 4x squared minus 2x plus 8 and 10x squared minus 3x minus 7? Okay, so right away, I want to look at my key term, right? So my key term is sum. And I know from my reference table at the very top of my page that sum indicates that I actually need to add. So I'm going to take this first expression, right, 4x squared minus 2x plus 8, and I'm going to add it, right, to this expression over here. And whenever I'm adding expressions together, I want to make sure that I'm putting them in parentheses. So let me put some parentheses around here so I know that that's my first expression. My second expression is 10x squared minus 3x minus 7. The reason why I want to actually put parentheses between my two expressions that I'm doing an operation on is in case that I'm subtracting, right? I would actually have to distribute a -1, and so I want to make sure that I'm distributing correctly, so that's why I want to make sure that I'm putting the parentheses there. So over here, when I'm adding these two expressions, right, I could actually just distribute a +1 because I know that there's a secret 1 hiding there. So I'm going to just multiply that 1 to everything in that parentheses. I'm going to get 4x squared minus 2x plus 8 plus 10x squared minus 3x minus 7, right? It stays the same. Now what I want to do is actually combine my like terms. So when I'm looking at this, right, I see my first term is 4x squared. I want to look around the rest of my expression to see whether or not I have another term with an x squared in it. and I see 1 right over here, my 10x squared, right? And so when I combine those two, I should end up getting 14x squared. All right, my next term that I see is negative 2x. Do I have another like term to negative 2x? So that means that I want to look for a term in my expression that just has an x, right? And over here I have negative 3x. I'm going to carry that sign over, right? So when I have these two terms, negative 2x and negative 3x, and I'm combining them, it's the same as negative 2x minus 3x, which is minus 5x. All right, and then I'm going to move on to my last terms, right? So I have this constant plus 8. I have another constant here, minus 7. So 8 minus 7 gives me plus 1. And so this is going to be my final expression. Okay. My next question says, if 2x minus 3 quantity squared is subtracted from 5x squared, what is the difference? Okay, so from my reference sheet, right, at the top of my page, I know that 2x minus 3 quantity squared, this expression right over here, that's actually equivalent to 2x minus 3 times 2x minus 3. Now, in order for me to actually subtract, right, and combine like terms, I want to make sure that I'm multiplying those two expressions out. And the method that we talked about that we really liked in our class was the box method. You could also use FOIL, but for this purpose, I'm actually going to use the box method. So whenever I'm using the box method to actually multiply this expression out, I want to first, as the name suggests, draw a box. Right? I'm going to put my first expression, 2x minus 3, at the top of my box, 2x minus 3, and draw a line down to separate those two terms from each other. Okay, so for my next side of my box, right, the left-hand side, I'm actually going to put the second expression, which turns out is the same, but write it going down. Right, 2x minus 3, once again, draw that line to separate those terms. Okay, now all I want to do is actually multiply the sides of my boxes together. So I have 2x times 2x, which is 4x squared. Know that this side is actually 2x because it's the same as the opposite side to it, right? So 2x times negative 3 is negative 6x. Over here, I know that this side is actually 2x because that's the side opposite from it. So when I multiply these two sides together, I get negative 6x. And then I know that this side is negative 3, this side is negative 3. Negative 3 times negative 3 is positive 9, right? So these are actually the terms I want to bring out so that I can combine them to get a more simplified expression, right? So this is going to be, let's move down a little. This is going to be 4x squared minus 6x plus 9. Right? I have these like terms over here, so I'm going to combine them to get 4x squared minus 12x plus 9. Okay, so I just simplified that expression, but I'm not done, right? So I know that I just simplified this expression right here, 2x minus 3 squared, to 4x squared minus 6x plus 9. Now, what I want to do is I want to subtract it from 5x squared, right? And I remember that from my reference sheet, whenever I have this phrase subtracted from, I actually have to do a special thing and actually reverse these terms when I write my expression. So let's actually write that expression out. So instead of writing my 4x squared minus 6x plus 9 expression, I'm first going to write my 5x squared expression. And then I'm going to subtract that expression that I just simplified, right? So 4x squared minus 6x plus 9. Remember that whenever I'm subtracting or adding expressions from each other, I want to make sure that I'm putting them in parentheses so that I can actually distribute this correctly, right? And this comes in handy whenever we're doing subtraction, right? Because that means I actually have to distribute a negative 1. So I'm going to multiply that negative 1 to everything inside my parentheses to get 5x squared minus 4x squared plus 6x minus 9, right? Over here, I have these like terms, 4x squared minus 5x squared minus 4x squared. And so I'm going to combine them to get 1x squared. And then I don't have any other like terms, so I'm just going to bring down all my other terms. Just write that a little bit neater. Plus 6x minus 9. and that should be my simplified expression. So it's combining a few of these different skills that we've been covering, right? So it's combining multiplying, using our box method or FOIL, and it's also using our decoding skills from word problems and also combining like terms. Okay, so my expression says if a equals 3x squared plus 5x minus 6, and b equals negative 2x squared minus 6x plus 7, then a minus b equals, so I want to figure out what this expression is equivalent to, right? This expression over here. Now I know some things, right? I know what a equals. I know that a equals this expression, 3x squared plus 5x minus 6. I know that this expression b equals negative 2x squared minus 6x plus 7, right? And I want to figure out what this expression equals, so I'm actually going to just substitute those values in. Remember, whenever I substitute, I want to put in parentheses. All right, let me just make note of that. When I'm substituting, I want to put this in parentheses. This is going to ensure that we always get the right answer. Okay, so let's try it out. My a is this expression right over here, right? 3x squared plus 5x minus 6. And then I want to subtract, right? So I'm going to subtract b right over here, right? Negative 2x squared minus 6x plus 7. Okay, now remember, whenever we're subtracting an expression, it's like distributing out a negative 1. So I need to distribute that negative 1 to everything in my second expression. And so when I do that, right, I didn't do anything to my first expression, so I'm just going to bring it down, and I'm going to take away the parentheses just because I don't really need them anymore. Now, my new expression, after I've distributed out the negative 1, is going to be negative 1 times negative 2x squared is positive 2x squared. Negative 1 times negative 6x is positive 6x. Negative 1 times positive 7 is negative 7. Now, I can combine some like terms, right? I see that 3x squared is a like term to 2x squared, right? So I'm going to combine them to get 5x squared. Okay, next one. I have 5x, right? Like term to 6x, so I'm going to combine them. 5x plus 6x is 11x. And then finally, negative 6 and negative 7. Negative 6 minus 7 is negative 13. Right? So this is going to be my final expression. Let's try the next one. If the difference 3x squared minus 2x plus 5 minus quantity x squared plus 3x minus 2 is multiplied by 1/2 x squared, what is the result written in standard form? A lot of steps to do. Let's break it down, right? Let's try out the first part of the sentence, right? We see this algebraic expression right over here that doesn't look fully simplified. And I think that we can actually simplify it. So let's actually just simplify it right below. So we know that instead of dealing with this big expression over here, we're just going to deal with our simplified expression. So once again, I see that I'm subtracting another expression, right? So I know that I need to distribute out a negative 1, right? So when I do that, I didn't do anything to this first expression over here, so I'm going to bring it down. 3x squared minus 2x plus 5. And once I distribute that negative 1, I get negative 1x squared minus 3x. Negative 1 times negative 2 is positive 2. Okay, I'm going to combine some like terms. So I have 3x minus 1x squared, which is 2x squared. Negative 2x minus 3x is minus 5x. Positive 5 plus 2 is plus 7. Okay, so this is going to be the new expression that I'm dealing with before I move on to my next step. Let's see what that next step is, right? It says to multiply, whoops, let's change it to a different color. It says to multiply that expression that I just simplified by 1/2 x squared, right? So I'm going to take this expression that I have, 2x squared minus 5x plus 7. I'm going to multiply it by 1/2 x squared. Right? Looks like I have a monomial times a polynomial, so I'm going to use my distributive property, making sure that I'm taking care of the sign whenever I multiply. So I have 1/2 x squared times 2x squared. I know that 1/2 times 2 is 1, x squared times x squared, I need to just add the exponents. So I keep the x, right? And when I add the exponents 2 and 2, my new exponent is 4. Now, I have 1/2 x squared times negative 5x, right? Negative 5 times 1/2 is negative 5 over 2. X squared times x to the first power, right? I'm going to add the exponents. So I keep the x, and 2 plus 1 gives me a new exponent of 3. 7 times 1/2 is just 7 over 2, right? I don't have an x squared or an x over here, so I'm just going to bring the x squared over. Okay? So, looks like after I multiplied by 1/2 x squared, I end up with this expression. Let's just figure out what that final part is, right? It asks me, what's the result written in standard form, right? And if we think about standard form, we want to make sure that our exponents are going from highest to lowest, right? So let's just write that definition right over here. We have exponents going from high to low, right? And let's just double check that our exponents are going from high to low. My largest exponent is right over here, right? It's this 4. So because that's my largest exponent, it should go first. It is the first term in my expression. Looks like we're good, right? 3 is my second highest exponent, right? It is the second term in this expression. Looks like we're still in order. 2 is my lowest exponent. It's the last term in my expression. Looks like we did that correctly. So it already is in standard form. So it looks like we have our answer right over here. Okay, let's move on to the next one. We want to subtract 5x squared plus 2x minus 11 from this expression 3x squared plus 8x minus 7 and express the result as a trinomial. Okay, so remember, whenever we see this phrase, subtract from, right, it's like we need to actually reverse these two expressions. So instead of writing this expression minus this expression, we actually need to reverse it. So let's just write it out. So my first expression I'm going to write is 3x squared plus 8x minus 7. And then I have this keyword subtract from, so I'm going to put a subtraction sign there, right? And then because I'm subtracting, I want to make sure that I'm writing my parentheses, right? Whenever I'm doing an operation, I want to write my expression in parentheses. I'm going to put that first expression I see there in this parentheses, 5x squared plus 2x minus 11. Now, because I'm subtracting, it's like I'm actually multiplying by -1 and distributing it out. So once I distribute the negative, my new expression is going to be my first expression that I didn't do anything to, 3x squared plus 8x minus 7. Okay, and then -1 times 5x squared is minus 5x squared. -1 times 2x is -2x. -1 times -11 is plus 11. And now I want to combine my like terms, right? So my first like term that I see over here is 3x squared and minus 5x squared, right? So 3x squared minus 5x squared gives me -2x squared. Next one is 8x and minus 2x. 8x minus 2x is plus 6x. And then finally, my last one right over here, minus 7 and plus 11, right? So -7 plus 11 should give me positive 4. Okay. Let's see, do we have any other part, right? It says to express the result as a trinomial, right? Whenever I think about the word trinomial, let me just annotate that. I want to think 3 terms because we have that root tri, right? So we have 3 terms. Okay, and then when I look at my expression, I see that I do have 3 terms right over here. So it looks like I did that correctly. Okay, 7th problem. What is the sum of 2x minus 3 squared and 5x squared plus 1, right? So first things first, I want to look at what keyword I have. I have this word sum, which signals to me that I need to actually add this expression with this expression. Okay, and then I see that I'm squaring an expression, so that means I can do the box method. From a previous problem, we actually already multiplied this out, so I'm not going to do it again. You can go back to question number 3 in order to figure out how we actually did that. But 2x minus 3 quantity squared, we actually found out was going to be, let me just write it down underneath here, 4x squared minus 12x, that's correct, plus 9. Right. So I want to add this expression, 4x squared minus 12x plus 9, with this expression, 5x squared plus 1. I'm putting it in parentheses just to keep it consistent with what I've been doing in other problems. Right. So whenever I have this plus in front of my expression, I know that this is the same as distributing a positive 1. Whenever I distribute by positive 1, it ends up giving me the same expression. So my new expression should really be 4x squared minus 12x plus 9 plus 5x squared plus 1. Right? Here are my like terms. 4x squared, 5x squared. 4x squared plus 5x squared gives me 9x squared. My next one is negative 12x, right? And it doesn't have a like term with any other term in that expression, so I'm just going to write it down here, negative 12x. And then finally, what color should I do? Blue, right? So plus 9 and plus 1, these are like terms because they're both constants. 9 plus 1 is just 10. That's going to be my final expression. Let's just double check to see that I answered the question. I did. They were just asking about the sum, and I found the sum, so I'm good. Let's look at question number 8. It's asking us to find the product of 2x minus 3 times 3x plus 5, right? So the product is asking us to find, to multiply, right? So we want to multiply these two. I see that I'm multiplying a binomial times a binomial. And the method that we know to do with this is the box method. So let's actually just do the box method, right? If you want to use FOIL, that's fine. In our class, we just really like to using the box method, so that's what we're going to use. All right. So for the box method, first things first, let's draw a box. Okay. I'm going to take my first expression, right? I'm going to color code that my first expression is green. Okay. So I'm going to write my green expression, 2x minus 3 at the top. I'm going to draw a line that separates those two terms from each other. Now my next expression is 3x plus 5. I'm going to color code it in red. Okay, so I'm going to write that on the side of my box, on the left-hand side of my box, going down, 3x plus 5. I'm going to draw a line that separates these two. Right. Now, before I get started, I know that this is something that a lot of people struggle with the box method, so I want to just actually pre-annotate some of my sides of my box, right? So let me just zoom in a little bit. So we're just focusing on this box, right? Now, when I'm looking at this box right over here, this side right over here, right? Because it's opposite to this 3x, let me just get that out of the way, this 3x right over here, I know that this side is also going to be 3x. Okay, let's focus on this side right over here, right? I see that it's actually opposite to this negative 3, so I know that it's going to be equal in measure, right? So I know this side is also going to be negative 3. Okay, let's focus on this side over here, right? Let me just highlight it. This side over here, it's opposite to this plus 5, so this side is also going to be plus 5. And then finally, one more side that we haven't really annotated quite yet is this side right over here, right? Now it's actually opposite to this 2x over here, so I know it's going to be the same measurement, and this is also going to be 2x. So now that I have this information, I can actually go ahead and start multiplying my boxes, and hopefully I might be able to see what those lengths and widths should actually be a little bit easier. Okay. Let's actually try multiplying some of these boxes together, right? So for my first box, I'm going to be multiplying my length and my width together, which is 3x times 2x. So my resulting product is 3x times 2x, 3 times 2 is 6, x times x is x squared, right? And so this is my product of my first box. Let's try my second box, right? I see that I'm multiplying 3x times negative 3, 3x times negative 3, and so that's going to be negative 9x, and that's going to be the product of my second box. Okay, let's try this box out, right? I see that my length and my width are 5 and 2x, so I'm doing 5 times 2x, which is 10x, and that's the product of my third box. Let's try the last one. Let's try this last box over here. Thanks to my pre-annotating, I actually can see that I'm just multiplying 5 and negative 3 together. So 5 times negative 3 is negative 15. Right, and that's the product of my last box. So now that I've found all the products of my tiny boxes inside my big box, I'm going to take it out. When I take out all of these terms, I should end up with something that looks like this. 6x squared minus 9x. That's a positive 10x, so I'm going to write plus 10x and then minus 15. Now, we just have to find the product, but whenever they say find the product, I think that they really are implying that we give it in simplest form, meaning that if we have any like terms, we combine them. And over here, I see that I have two like terms, right? I have my negative 9x and I have my plus 10x, so I'm going to combine them to get 1x, right? And I didn't do anything to my other terms, so I'm going to bring them down. And that's going to be my final expression. For our ninth question, right, we want to express the product of 2x squared plus 7x minus 10 and x plus 5 in standard form. So once again, we want to look to see what our key terms are. So we want to do the product, right? So that means multiplication, right? And standard form, that's telling us exponents go from highest to lowest, right? We have these two expressions. Let's figure out what our expressions are. Our first expression is 2x squared plus 7x minus 10. Our next expression is x plus 5. Whenever I'm doing products, right, I can do FOIL, or I can, once again, do the distributive property. The box method. Right? So when we're doing the box method, let's draw a box. So I'm going to draw a box. Actually, I'm going to draw it a little bit further away. Okay. Now, once again, I put my first expression, 2x squared plus 7x minus 10, at the top. I'm going to draw a line separating each of these terms. 2x squared plus 7x minus 10 is actually a trinomial, so there are 3 terms, so I should be drawing 2 lines to separate them out. Alright, so my first term is 2x squared, my second term is positive 7x, my third term is negative 10. Now for my next one, my next expression, I have x plus 5, so I'm going to write that on the left-hand side going down. So I'm going to write x plus 5. I only have 2 terms there, so I'm going to draw 1 line to separate them out. Now, this is where it comes in handy to actually annotate, pre-annotate your side links, right? So I see that these 2 lines over here, here, these are actually going to be the same value as this, this expression that we have over here, x. Right, so I'm just going to annotate that, right? This is also x, this is also x, because they're directly opposite, so they're going to be the same side length, right? Now over here, right, this side and this side, it's opposite from that side length plus 5. So I know that this side length is actually going to be plus 5. This is also going to be plus 5. Okay, now let's deal with these middle lengths, right? So this middle length over here, this middle length over here is opposite from 2x squared. So I know that it's going to be 2x squared over here as well. this side length is opposite from plus 7x, so this is also going to be plus 7x. And then finally, this side length over here is opposite from negative 10, so this is also going to be minus 10. Now that we've fully annotated our box method diagram, let's actually use that in order to figure out what should go inside the tiny boxes, right? So over here, we're going to be multiplying 2x squared times x, and that is equal to 2 times 1 is 2, x squared times x is x to the third power. So this is my product. Let's move on to the next one. I'm multiplying 7 and 7x and x, so this is 7x times x. This is going to be 7x squared. That's my product. I'm going to be multiplying negative 10 and x to get negative 10x. That's my product there. Let's move on to the next one, right? I'm multiplying 5 and 2x squared, because I annotated that right over there. So that's going to be 5 times 2x squared is equal to 10x squared. Great. Next one. Thank God I annotated, because I know I'm multiplying 5 times 7x, right? So I have 5 times 7x. That equals 35x. Once again, good work on annotating, so I'm going to do 5 times negative 10, which is negative 50. That's my product, right? So what do I do with all these products, right? I take them out. So let me zoom out a little bit, right? Actually do something with these products, right? So I have 2x squared plus 7x, oh, sorry. That's 2x to the third power plus 7x squared minus 10x. And then I have plus 10x squared plus 35x minus 50. Whew, okay. A lot of terms. Let's see if we can combine any to make sure that we have as few terms as possible so it's in simplest form, right? When I look at my first term, 2x to the third power, I don't see another term with x to the third power in this expression, so I'm just going to bring that down. There's no like term to combine with it. It would help if you could see it. Let me see. 2x third. There we go. Now, let's move on to our next term, positive 7x squared. I do see that I have a positive 10x squared over here, so I can combine those terms. So plus 7x squared plus 10x squared is 17x squared. My next term that I see over here is this minus 10x. It's a like term to plus 35x. So negative 10x plus 35x is going to be positive 25x. I don't have another like term to minus 50, this constant term I have over here. So I'm going to bring it down. And remember, I want to check that this is in standard form. So let's make sure that my exponents are going from highest to lowest. My highest exponent is 3. That's my first term. My second highest exponent is 2. That's my second term. My third highest exponent is 1, which is my third term. And my last term is a constant, so I know that it has an exponent of 0. So it looks like this is in standard form. And I'm good. Now, this one seems like a very long, complicated problem, but let's actually just break down what it's asking us for, right? So let's read it through first. A company produces X units of a product per month, where C of X represents the total cost and R of X represents the total revenue for the month. The functions are modeled by C of X equals 300X plus 250, and R of X equals negative 0.5X squared plus 800X minus 100. The profit is the difference between revenue and cost, where P of X equals R of X minus C of X. What is the total profit P of X for the month? This is actually very similar to a problem that we just dealt with earlier where we were doing A minus B, and they told us that A represented this expression and B represented this other expression, right? So let's actually use that knowledge that we learned from that problem in order to help break this down, right? So don't even worry about what the first part of the paragraph is telling you. Don't worry about that first sentence because it's not really going to help us with this problem, right? what helps us with this problem is we know exactly that this c of x is represented by this expression, right? And this r of x is represented by this expression. And then finally, p of x is this expression, right? It's a difference. So we want to do r of x, this expression. Oops, let me do it in green. This expression minus this expression, c of x. Okay, so let's write that out. Let's actually substitute those expressions in. So p of x is going to be equal to r of x, which is negative 0.5x squared plus 800x minus 100 minus, right, c of x, this blue expression over here, so 300x plus 250. Remember, I'm putting everything in parentheses just in case I'm subtracting. Turns out I am subtracting, so this is actually pretty helpful that I did that, right? So when I'm subtracting, it's the same as distributing the negative, right? So it's like I have an imaginary negative 1 there, so I'm going to multiply it to everything in that parentheses, right? And when I do that, I end up getting negative 300x minus 250. Okay, and I didn't do anything to this first expression, this green expression over here, so I'm going to actually bring it down. Negative 0.5x squared plus 800x minus 100. All right, this looks a little bit more manageable, right? It looks like I can actually combine some like terms. So I had this like term over here, plus 800x with negative 300x. So 800x minus 300x, that actually gives us plus 500x. I have another like term, right? I have negative 100 and minus 250. So negative 100 minus 250 is minus 350. Okay. And then I didn't do anything to that negative 0.5x squared, so I'm just going to bring it down. I'm going to make sure that it goes first, right? Because my exponent for that is 2, which is higher than all of the other exponents I see going on here. So I just wrote it in standard form. That's going to represent my expression for p of x. Okay, so this is just a combining like terms problem, but it was also just making sure that you knew how to distribute a negative when you're subtracting two expressions together. Okay, so this is the last problem for reviewing operations with polynomials. If you are struggling with this, make sure that you're circling any questions that you are really having a problem with. And please refer to the review videos I'm going to be listing up in the cards and at the end of the video in order for you to actually fully understand what you're doing with this unit. So now we're going to switch modes and go into functions versus relations, right? This is still related to Algebra 1. A lot of these questions are going to be very similar to the functions questions that would show up on the Algebra 1 regions. So we're actually going to be focusing a lot on regions-based questions on functions versus relations in order to help us prepare for this topic on the task exam. So let's start over with the review that was given to us on our review sheets, right? So there are some things that you should know going into this and some things that you should be able to do. If you're going through this and you're like, what the heck is this? What the heck is that? I don't know how to do this. I don't know how to do that. Then pause, go to those review videos that I'm putting in the cards in this video, and just go over them, review them before getting started on these review problems, okay? So let's go over some of the things that we should know. Right, and maybe when we talk about them, it'll jog your memory about talking about them in a previous lesson, right? So we need to know about coordinates, right? So specifically an ordered pair. An ordered pair gives us basically a location on a grid for a point. We should also know about what a relation is. So it's a set of ordered points, of ordered pairs or points. And sometimes relations can be functions, right? If they follow the definition of a function, but not all relations are functions. When we do have a function, we have specific elements called domain and range, right? This is going to be really important. I'm actually going to do a more in-depth lesson about this later on, but because this is just review right now, we're just going to quickly go over them, right? So domain, all the x values in a relation or in a function, and a range is all the y values in your relation, right? And a function is a relation in which every x value corresponds to one and only one y value, right? So this really means that every x has one y. And we're going to see what that looks like in various representations, but whenever we're trying to determine whether or not something is a function or is not a function, we always want to think back to the definition, right? We're going to see a lot of real-world domain and range questions. So this is talking about putting functions into a real-world context. And so we want to make sure that we're using our reading comprehension skills and just like basic life skills in order to help us figure out these questions. So it really depends on the situation that's being presented to you. But at the end of the day, you want to just trust yourself, ask yourself what makes sense, right? So you want to make sure, can you have negative values in the situation? So in situations that are talking about height or time, you can't really have a negative height or negative time. So you know you're not going to have negative values. So another situation might be like, let's say that you're trying to split up people into a group, right? If you're splitting people up into a group, you can't split half a person into a group. So you know that maybe for that situation, you should only have whole numbers and you can't have decimals or rational numbers, right? And then another example would be like positive integers represent the number of workers at a construction site. So you can only have a positive whole number of people working at a construction site, or a positive whole number of cars at an intersection, right? So you really just want to think what makes sense based on my situation. So now that we know what you should know, right, what should you be able to do, right? So you should be able to tell whether or not a relation's a function through a variety of representations, right? So over here, it's through a table. Over here, it's through a graph, right? And we can always tell whether or not a relation is a function by doing the vertical line test. I'm going to go over some examples about that in a little bit, right? And then also through something called mappings, right? Mappings are so useful and a great way to visually represent what a relation looks like. In addition, you should be able to find the range of a function given the domain, evaluate a function for a given x value, make a table of values to graph a function, and write a function rule from a table, right? So if we know how to do all of this, you are so set for the TAFE exam with questions regarding functions. So let's actually test where we're at right now. If you went through this list and you're like, I have no idea what any of these words means, just stop and go to those review videos that I talked about. Do some of those review practice problems that are on the website, okay? Let's start with this example. So it's asking us whether this relation, the set of coordinates, is a function, right? And so one way that I can tell whether or not this is a function is I want to think back to my definition of what a function really is, right? So this is saying 1x for, other way around, right? Even I get confused sometimes, right? So for every x, there's only one y value connected to it, right? So if you ever have an x that repeats and it has a different y value, like let's say here, we're at 2, 5, and over here we're at 2, -3, this x value has two different y values, right? So because this x has more than one y, this is not a function, right? Because it doesn't fit the definition that we said for a function. So our explanation would be, this is not a function because the x value 2 has two, let me write this out as a word, two different y values. And I want to specify what those y values are just so that I'm as clear as possible, right? So my first y value that I have connected to an x as 2 is 5, and my other one is -3, right? Because it's mapping to two different y values, this is not a function, okay? And then when we actually connect it back to representing relations on graphs, representing relations as mappings, right? We can more clearly see this, right? But then generally whenever you're given a relation as a set, you want to just look to see is your x value repeating, right? So is x value repeating? Right? If it is, most likely it's not going to be a function because it's probably going to have a different y value associated with it. All right, next one. It says to find the range of the function rule, h of x equals 5x minus 2 for a domain of -1, 2, 0. All right, so when we see this word domain, we want to think about inputs, right? So this domain is talking about inputs. Okay. When I look at my function, I'm seeing that my input is x, right? So my input, or my domain, is going to be my x values, right? So these are all x values. So in order to find my range, right, my function is only defined at those x values that were given to me. I'm just going to evaluate my function at each of those x values. So my first function evaluation is going to be h of -1. And this really means every time I see an x in this expression over here, I'm just going to substitute in -1. So I'm going to do 5. Instead of x, I'm going to do parentheses -1 because whenever I substitute, I put it in parentheses, -2. I'm not going to evaluate that right now. I'm actually going to set up my function expression for the other x values I have in my domain, right? So for my next one, I have h of 2 equals 5 parentheses 2 minus 2. Let's try out my next one, right? H of my next x value or domain value is 0, so I'm going to substitute and evaluate at 0. So I have 5 parentheses 0 minus 2. All right, so I just set that up. Now I just want to actually evaluate them. This would actually sometimes be a calculator question. I would actually just try to recommend, if you can do it in your head, just to save time, like just do it in your head. But if doing these small calculations like that, it takes a lot of time just because, like, you know, you struggle with your times tables or something like that, don't worry about it, just use your calculator, okay? Let's try this out. So we have 5 times -1, that's -5 minus 2. -5 minus 2 is -7. So that's going to be our first range value, right? Because our range are just our y values, just like how our domain are our x values, right? 5 times 2 is 10 minus 2. 10 minus 2 is 8. So second range value. And then finally, 5 times 0 is 0 minus 2 is -2. That's my third range value. Okay? So I'm going to write my range now, right? So my range, just like how my domain was written in these curly brackets over here, right? These right over here, just so we know what I'm talking about. I'm going to write my range in curly brackets too, right? So my range is going to be curly bracket, -7, comma, 8, comma, -2. Close curly bracket. And that's it. So this is really telling us whenever we're trying to find the range given a domain, so let's just highlight this language, find the range for a domain, right? This is actually just telling us evaluate at certain x values, or whatever your input is. It could be a, it could be whatever letters inside the parentheses over there, certain x values. Okay, let's try out the next one. All right, evaluate the function f of x equals x squared plus 2 for x equals -3. All right, this word evaluate is just a really fancy way of saying just substitute, right? Substitute, you might have heard it said in middle school as plug it in. I don't like saying plug it in. Let's actually be mathematical with our language, but it's the same concept, right? Every time you see whatever's in the parentheses, so in this case it's x, right? Whenever you see that in this expression, you're going to just be substituting in this value. So let's actually try that out. So I have f of x equals x squared plus 2. Okay, that's my original expression, or that's my original function, right? It's telling me to substitute in -3. So I'm going to do that. So f, instead of writing -3 for x, I'm going to, instead of writing x, I'm going to write in -3. And then I'm going to write in -3 one more time, again in parentheses. Whenever I substitute, I'm going to put it in parentheses, or else I might not get the right answer in my calculator. and then plus 2. Okay, negative 3 squared is the same as negative 3 times negative 3, so this should be a positive 9. Remember, a negative times a negative is always a positive. And then plus 2. And then 9 plus 2 is 11, so this is going to be what f of negative 3 is. Okay? All right. Nora says that the graph of a circle is a function because she can trace the whole graph without picking up her pencil. Mia says that a circle graph is not a function because multiple x values map to the same y value. Determine if either one is correct and justify your answer completely, right? Okay. So, let's just actually draw a graph on a circle. Draw a circle on a graph. There we go. Having trouble with the language today. Okay, so let's say that this is my coordinate plane. Pretend that's straight. Pretend this is straight, right? If I draw a circle on here, right? Whenever I'm given a graph, I want to do my vertical line test, right? And so this says that if I draw a horizontal straight line going, sorry, not horizontal, a vertical straight line going down, I should never hit my graph more than once, right? But if I draw my vertical line going down on this graph, right, I hit my graph here, I hit my graph here. This is not a function, right? So I know just based on the vertical line test, so based on vertical line test, not a function, right? So when I look at the original statement that's given about what Nora says, Nora's wrong, right? So Nora's wrong. And it's because that circle doesn't pass the vertical line test. Now let's look at Mia's reasoning. Mia says that the circle graph is not a function. Okay, so that seems to check out so far. But let's look at her reasoning. It says multiple x values map to the same y value. Now this language is kind of confusing, right? So this is saying that your y can have multiple x's. So one y for multiple x's. Right? But that's not the definition of what makes a function, right? If it were not a function, it would be one x has multiple y's. That should be the reasoning that she should be given, not this, right? So her reasoning actually doesn't match the function definition. So what I'm going to say is neither are correct. Neither Nora nor Mia are correct. Nora is not correct because she said that it was a function, and we just proved that it wasn't a function, right? So because a circle graph is not a function, because it doesn't pass the vertical line test. Whenever we have a graph, just do the vertical line test. It doesn't pass it, right? Doesn't pass the vertical line test. I'm going to abbreviate it as VLT, okay? And then Mia is also incorrect because she does not give the correct definition of a function. She uses some faulty definition as her reasoning, and she actually gets it mixed up, right? When we do the vertical line test, this is actually just proving the definition of what a function is, right? Because over here, if your vertical line crosses your graph more than once, right? Let's actually create a coordinate for this, right? So let's say that this coordinate is actually, what, like 2, -4, right? Let's say that that's your coordinate over here. If the vertical line were passing through, right, this would actually have the same x-coordinate, 2, but it would have a different y-coordinate. So let's say that this is +4, right? Same kind of thing as before, right? You have the same x value but different y values. That's exactly why the vertical line test works, right? Because it's based off the definition of what a function is. Okay? If you were having trouble with this one, The wording's really, really weird. You probably would not see a question like this on the tax exam, so don't worry too much, but it's really testing to see whether you know the definition of a function back and forth, right? If you don't, really got to commit to memory, try out a few examples, and actually test for yourself, why do some of these tests that we use actually work, right? If you can't come up with a reason for it, then that means that something's maybe not totally connecting. So I really suggest that you go back to your notes, go back to the review videos before moving forward. All right, let's try this one out. It's asking which table represents a function. This is a multiple choice question, right? Whenever we have a table, it's very similar to how we would evaluate just relation sets, right? So we do this by seeing, does your x repeat? Right? If it repeats and if it repeats and you have different y values, right, then you know that it's not a function. Okay, so let's look over here. I want to look at my x row right over here, and I'm seeing that 2 and 4 actually repeat, but I'm just going to check with 2, right? So with 2, I see that it has a y value of 3, but then over here it has a y value of 7, right? So because it has 2 different y values, we know that this is not a function. Okay, let's try out the next one. Right, I have an x value of 0. I'm going to do this as green. Right, an x value of 0, and then my y is 0. Over here I see x as 0 again, but then my y value is different, right? So this is also not a function, right? I have 2 different y values for the same x value. Let's try this one out. Option C. This is looking good, right? Because I'm not seeing any x values repeating, right? 3, 5, 7, 9, those are all unique values. So I'm going to say that this is a function, right? Because no x value repeating. But I'm just going to check the last answer option just to make sure, right? And once again, lo and behold, we have 0, 0 here, right? So your y is 0 when your x is 0. But over here, when your x is 0 again, you have a different y value, 1, right? So this is not a function. Not a function. Because it doesn't match the definition for what a function is, right? So we know that our answer choice is going to be C. Okay? A function is shown in the table below. If included in the table, which ordered pair, -4, 1, or 1, -4, would result in a relation that is no longer a function? Explain your answer, right? So, whenever you're asked to find or decide between 2 different coordinates to make your function not a function, right? Let's just highlight this language. It's no longer a function, right? We want to think back. When we have a table, when we have a set, what do we look for to see whether or not it is or is not a function, right? And if your x repeats, then it's not a function. So let's look, right? I have -4, -1, 0, 3, right? Let me just highlight that. -4, -1, 0, 3, right? Those are my x values. As long as my coordinate that I'm going to be adding in has an x value that is the same as one of the x values in the table already, that will make my relation not a function. Make my relation not a function. Right? So when I look between these 2 ordered pairs, right, -4, 1, and 1, -4, I actually don't have a 1 and x equals 1 in my table, so I know that this is not going to be my answer, right? But I do have an x equals -4 in my table, So I know that this is actually going to be my answer. So my answer is going to be 4, negative 4 comma 1, right? So negative 4 comma 1, right? And I can see that if I were to put this in my table, right? Let's put this in my table. Let me just erase this a little bit. If I were to put this in my table as negative 4 comma 1, right? I see that negative 4 comma 2 is one element in my table, right? And then negative 4 comma 1, right? Same x value, but different y value. Okay, now this one's a little bit of a doozy, right? It's a bunch of different representations, but we just want to think back to graphs, tables, mappings, sets, right? They all have a clear way, a clear method of determining whether or not that's going to be a function. So when we look at this, right? 1 through, sorry, I don't mean to keep zooming in and out, right? So let me just highlight the ones that I want to use my vertical line test on because they're going to be graphs, right? So 1, 2, 4, 5, and 6. Every time it's green, right? Let me just make a note of that here. Every time this is green, I'm going to use my vertical line test, right? Because it's a graph, that's my clearest way of determining whether or not a graph is a function. Now, when I have my mappings, right? I have one mapping here. I'm going to label that, let's label that yellow, right? So when I'm yellow, I just want to see 2 arrows out of one x value, right? If I see 2 arrows coming out of one x value, then this is not a function. Okay? And then finally, for relations that are represented as sets, right? I'm going to make those blue. Whoops. Let me highlight those. Right? Whenever we have something that's labeled as being blue, we want to make sure that we're using our rule that we want to just look for one if our x value repeats, right? So if it's blue, is our x repeating? Because if it's repeating, then it's probably not going to be a function as long as the y value is different. Okay, let's draw out the greens. Okay, I'm going to draw a bunch of vertical lines going down, right? Vertical line, vertical line, vertical line. I only ever hit one point at a time. See, I hit a point here, 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 here. There's only ever one point on my vertical line. So because it does pass the vertical line test, right, this is a function because passes VLT. Great, let's move on. This is also green. Once again, gonna just draw random vertical lines. It doesn't matter where you draw that vertical line, right? As long as it's hitting the graph so that it can actually tell you something. It never hits a point more than once. So it is a function because it passes the vertical line test. Okay, I'm gonna skip number 3 for now. I'm gonna move on to number 4 because it's also another green one. We can use the same method again. Gonna draw my vertical lines going down. Ooh, running into a problem. Okay, so the problem that I'm running into is over here. I see that on this vertical line, it's passing through 3 different points, right? Same thing on this vertical line, passing through 2 points. This vertical line passing through 2 different points as well. So because of that, this is not a function because it doesn't pass vertical line tests. Okay, let's try out number 5. Ooh, this one's hard. All right, just gonna draw a vertical line down over here because that's where I see my function. It's passing through that entire vertical line, right? So because it's passing through that entire vertical line, there's a point here, a point here, a point here. There are an infinite number of points passing through this vertical line, right? So not a function because it doesn't pass the vertical line test. Okay, this is actually something called an x equals equation, right? We don't really go into that for the task exam. We do occasionally go into that for Algebra 1, right? But that's just something to know extra in case, something like that pops up on the exam. Okay, and then last vertical line test kind of question, right? I'm once again just going to draw my vertical line going down, just randomly just dropping them just so that it touches my graph and I can just clearly get some information out of it. And I see that I only ever cross my graph once for any of these given vertical lines, right? So because it only passes each vertical line once, it is a function because it passes the vertical line test. Woohoo! So we're done with all our vertical line test questions. Let's move on to our mapping question, right? So remember, when we're looking at mappings and evaluating whether or not they're actually going to be functions or not, we want to see whether or not 2 or more arrows are coming out of one x value. And if more than one arrow is coming out of an x value, then it's not going to be a function, right? So over here in my mapping, right, I'm seeing this x value, -1, has 2 arrows coming out of it. Because it has 2 arrows coming out of it, it has more than one arrow coming out of it, this is not a function. Because this x value, because the x value -1 has mappings to 2 different y values, right? And in this case, the first mapping goes to a y value of 4, the second mapping goes to a y value of 5, right? So this is negative, oh, whoops, it's not negative, 4 and 5, right? That's the only mapping question that we have here. It doesn't really show up super often on the task exam. You mainly see questions that are like graphs and relations. So let's actually look at some relations as sets, because that's might be more helpful. Once again, we want to think back to our method of determining whether a set is a function or not. I want to see whether or not our x values are repeating. So my x values over here are 4, 2, and 6, right? Those don't repeat, so this is a function, right? Because our x values don't repeat. And when our x values don't repeat, that means that it follows the definition. Because it follows the definition, pretend that says definition, and you can read my horrible handwriting, of a function. Great. Next one. We want to see whether our x values are repeating. Let me just highlight my x values. I have -3, -3, -2. Looks like -3 is repeating, so not a function, because it doesn't follow the definition. Great. Next one. We want to see, are our x values repeating? My x value here is -1. My second x value is 1. My x values are not repeating, so this is a function because it follows the definition. Great. All these questions are really just asking to see whether or not you know the methods to check whether something a function is, and always double checking that you know what the definition of a function is, right? If it is a function, it should pass all those methods because all those methods were derived from the definition of what a function is. Let's try this out. So, beyond just the definition of a function, we want to actually look and see what some of the characteristics of functions are, right? And so this question, the graph of the function f of x equals square root of x plus 4 is shown below. The domain of the function is, right? And we see this keyword domain. When we say domain, we want to think x values or input values, right? And so my x values, right? The lowest x value that I can have is -1, -2, -3, -4. It's going to be -4, right? Because I don't see my graph extending to the left of -4, right? So it's all these values that are bigger than -4. And the way that I can represent that using an inequality is x is greater than or equal to -4. And I know that I'm going to have that equal to symbol right over here, right? Because this point at -4 is filled in, right? So because I have a filled in point, whoops, at x equals -4, right? And so the only set that matches the inequality I created is number 4, right? It has that x is greater than or equal to -4. And when I read this line, this vertical line, as such that means such that. Okay, so it says x such that x is greater than or equal to -4. But it's really just saying it's all these x values that are greater than -4, which is what this graph is representing. Let's try this one out, right? So for this one, it says if f of x equals the square root of 2x plus 3 all over 6x minus 5, then f of 1/2, right? And whenever we see this notation where we have a number inside the parentheses where we would usually have an x, right? This means to evaluate. So we're going to evaluate this. And remember, evaluate is the same thing as substitution. Right, so every time we see an x, we're going to just substitute in 1/2, right? So I have f of x equals the square root of 2 parentheses, because I'm substituting in, because I have that x there, 1/2 plus 3 all over 6 parentheses 1/2 minus 5. Okay, so I'm going to actually just start simplifying. 2 times 1/2 is just 1. Okay, 1 plus 3, square root of 1 plus 3, all over 6 times 1/2 is 3 minus 5. This is really square root of 4 divided by 3 minus 5 is -2. The square root of 4 is 2 divided by -2. 2 divided by -2 is -1, so my answer choice is 3. A toy rocket is launched from the ground straight upward. The height of the rocket above the ground in feet is given by the equation h of t equals -16t squared plus 64t, where t is the time in seconds. Determine the domain for this function in the given context and explain your reasoning. Okay, so this is a real life scenario, right? Because it's saying to determine the domain for this function in the given context. So let's think about the context, right? We're talking about a rocket, right? And then we're talking about the height of the rocket, right? Let me just highlight that, the height of the rocket. So when we're talking about height, right, we know that you can't have a negative height, right? So no negative numbers, right? And another thing is that when you have a height, right, you can have some decimal values, right? So can have partial values. Now, in the context of this review, right, you're not being asked to find like a vertex. You're just really being asked to find what would be a reasonable domain for this situation. And so if we combine both of these ideas together, we want positive. And when we can have partial values, right, we want positive rational numbers representing our height. Okay? That being said, the height is our y value in a sense, right? So our y value is our range. So this would be a reasonable range, right? When we're thinking about domain, right, we want to think about what's that value inside, right? It's just that value t is the time in seconds, right? So when we're thinking about time, right, time can't be negative, so no negative numbers. Let me just block this off. no negative numbers, right? And then also, you can have partial values, right? Like you can have 1.5 seconds, you can have 1.25 seconds, right? So can have partial values. Okay. And so once again, it's just asking for like a reasonable domain. If we were asking for the exact domain, you would actually have to factor, but that's not what we're doing right now, right? So once again, we can combine these two ideas, just like how we did for range, to get positive rational numbers. And so that would be our reasonable domain for this problem. You're just thinking back to just like context, what you know about real life, and just using your basic reasoning skills. Let's try this out. A construction company uses the function f of p, where p is the number of people working on a project, to model the amount of money it spends to complete a project. A reasonable domain for this function would be, right? And so once again, they're asking for a reasonable domain. If I look in this function, right, my domain is going to be p, that value inside the parentheses. And we know that p is the number of people working on a project, okay? So when we think of number of people, right, people, I know I can't have a negative number of people, so it has to be positive, right? And then I can't have half a person, right? So this has to be a whole number, right? We also can call whole numbers that are positive integers. So we need positive integers, right? And that's option 1. Let's look at this one. A store sells self-serve frozen yogurt sundaes. The function C of W represents the cost in dollars of a sundae weighing W ounces. An appropriate domain for the function would be, right? So once again, we're looking at domain, right? Domain is always going to be this value inside the parentheses. And we know that that W stands for ounces of a sundae, right? And so when we think about ounces, you can't have a negative weight, right? You can't have negative ounce, so it has to be positive, right? But you can also have 0 ounces, right? So can also be 0. In addition, you can have some like fractional ounces, right? So you can have something that we call rational or partial numbers, right? So if you're positive, but you can also be 0, we call this non-negative. That kind of encompasses those two ideas. And we know that we can be a rational number, so we're going to call this a non-negative rational number, right? And so that's going to be D. Let's look at this problem. Second to last problem. The graph represents the function g of x. Based on this graph, what is g of 0, right? We see that this means that our x is 0, right? So let me just zoom in. Our x is 0, right? So we want to look on our graph. Where is our x 0? We see that our x is 0 right over here. And so the y value, the g of x value, at that point is going to be 4, right? Because it hits right at 4. So g of 0, we can write g of 0 equals 4, because that's the y-coordinate when our x is 0. Now it's asking what is the domain and range of the function. So for the domain, right, we want to think about, domain, we want to think about our x values, right, x values. And so when we start writing our domain, especially in interval notation, we want to think about what's our lowest x value. And so the lowest x value that we hit, we actually don't know, right? Because this arrow indicates that this goes on forever and ever and ever. So we say that this is negative infinity. And this arrow tells us that we go to the right, to the positive values forever and ever and ever in our x. So we're going to represent this with positive infinity. For the range, our range is talking about our y values, right? So this is our y values. And so we want to think, if we're writing this in interval notation, what's the lowest y value that we hit? Our lowest y value, I'm going to say, is a little bit below -2, right? So I'm going to just say that this is, this is like a hard -2.25. Is that fair? Why not? And then these x values, once again, tell us that we go up forever and ever and ever, so we're going to represent that with an infinity sign and a parentheses because we can't really ever hit infinity, right? Okay, so that was the last problem. That was the entire review for the first day. These skills and these topics should be fairly familiar to you since that's what we've been covering for the past few months. But I want you to rate yourself on a scale of 1 to 5. 1 being, I don't feel confident about this at all, and I really need a review. And 5 being, oh, this is a piece of cake. I could have done this in 10 minutes. I did not need to hear you explaining this entire thing for me, right? So if you're at a 4 or 5, go ahead, move on to the next topics in this review. If you're at a 1 or 2, or maybe even like a soft 3, I would really suggest that you go back, review your notes, but then also watch those review videos and do those extra practice problems just so that you can get a sense of what you really need to focus on for this topic. All right? Thank you so much for your hard work. And remember to check on those review problems, ask questions, and ask targeted questions about specific problems that you are really struggling with. All right, take care.